Number 9. Okay, let's practice long division. The more you practice, the better you get. So we're going to put 6k to the 4th. I want to make it match so that when I subtract, it makes it disappear. So 6k to the 4th divided by k is 6k cubed. Now multiply. 6k cubed times k is 6k to the 4th. 6k times -9 is -54k cubed. Change the signs, subtract across, cancel. So we're going to have -3k cubed. Bring down the 29k squared. So we're going to make this one match. -3k cubed divided by k is -3k squared. Now multiply. -3k squared times k is -3k cubed. -3k squared times -9 is plus 27k squared. Change colors, subtract across, cancel, and we have 2k squared. Bring down -14k. We're going to make it match. 2k squared divided by k is 2k. 2k times k is 2k squared. 2k times -9 is -18k. Subtract across. Those cancel and you get 4k. Bring down the -36. 4k, make it match. 4k divided by k is 4. 4 times k is 4k. 4 times -9 is -36. Change the signs, add, we get a remainder 0. So equals that answer right there. Okay, number 10. Thank you for watching this video. You can cross it off. Do not do. Number 11, find all zeros. We could do rainbow and diamond, and we would find out that we cannot factor this one. So we are going to use quadratic formula. So plug these numbers, A, B, and C, into quadratic formula. Okay, so a couple of observations. This will always be positive if you remember to put your parentheses. So now simplify this 36 plus 24. So we get x equals +6 plus or minus the square root of 60 over 4. Now, if 60 did not have any factors that were perfect squares, then we would be done. But here are the factors of 60, and it has a factor that is a perfect square. So 60 is 4 times 15, which is 2 rad 15. So we have 6 plus or minus 2 rad 15 over 4. You could either split this into two fractions, or notice that all three of the outside numbers are divisible by 2. Divide all of them by 2. And we get 3 plus rad 15 over 2 and 3 minus rad 15 over 2. Okay, now we use the term rational to signify that these are fractions, rational expressions, fractions that have variables in them. Yay. So when we add fractions, let's review over here. When we add fractions, they must have a common denominator, and then we add the top. And then if we can reduce, we reduce. So it looks like I have a common denominator. So I'm going to add the tops. It's a little different. If it's subtract, you would have to distribute the negative. Combine like terms. Okay. Now look at all the terms. 6, 6, 34, 2. They all are divisible by 2. So let's go ahead and factor out the 6 from the top. Now we could cancel. That leaves a 3. Now, it looks like we can factor this expression on the bottom. But two numbers that multiply to get negative 15 and add to get negative 2, that's negative 5 and 3. So if I factored that, I would not be able to cancel anything. So I am going to leave it like this. Or you could also leave it 3m minus 3 over m squared minus 2m minus 15. Either one is correct. Okay, now we are going to solve radical equations, remembering that the opposite of a radical, the opposite of square root, is squaring. Super important. Now, what's the square root of 5 squared? That's the square root of 25, which is 5. Look what's happening. Square roots cancel squareds, and the 5 comes out. So square root of 7 squared is the square root of 49, which is 7. What's happening? Squared cancels the square root. So what is this? Square root of x squared. The squared is going to cancel the square root, and it comes out as x. So something important to keep in mind. Okay. So number 13, our first step is to isolate the square root. So we're going to subtract 3 from both sides. Now we've isolated the square root. The way to get rid of the square root is square both sides. Square root cancels squared. And now we're going to solve. Isolating the variable, subtract 25 from both sides. Equals 0. So if I have negative 5k equals 0, divide by negative 5. Can I have a 0 on top of the fraction? Yes. The answer is 0. Okay, number 14. Notice this is not 6 plus a radical. There's no plus sign. In fact, what is between the 6 and the square root? An empty space. That means we're implying multiply. So to isolate the square root, the opposite of multiply is divide. So we're dividing by 6. Okay, the opposite of square root is squared. The square root cancels the squared. V plus 2 equals 81. Subtract 2. V equals 79. Word problems. 8 daylilies and 2 pots of ivy give you $86. So daylilies, we're going to say is X, pots of ivy is Y. So we're going to say 8X plus 2Y equals $86. Okay, 3 daylilies, that's my X. 6 pots of ivy, that's my Y, equals $69. So 3 daylilies plus 6 pots of ivy is $69. Okay, so we have 2 equations in standard form. So we are going to use the elimination method. So choose a variable that we want to cancel. I think the y's would be easy to cancel. I just need to multiply the top expression by -3. Poof. That's going to be a -6. The y's are going to cancel. So multiply the top equation by -3. Okay, now we are ready to add down. Those are going to cancel. -21x is equal to 258. -258 plus 69, -189. Divide by 21, by -21. X is equal to 9. So a daylily costs $9. Now we're going to plug in to find the cost of a pot of ivy. Let's go ahead and plug into this one. So 6 times 9 plus 2y is equal to 86. Subtract 54. So 8 times 9 plus 2y is equal to 86. That's 72 plus 2y equals 86. Subtract 72. 2y is equal to 14. Divide by 2, y equals 7. So a pot of ivy is $7. So if we have a question right here, what is the cost of 1 daylily and 1 pot of ivy? So 1 daylily plus 1 pot of ivy is -9 plus 7 equals 16. Okay, number 16. Now, there are ways to solve this. If I have a 2-digit number, then I can write the value knowing that the digit in the tens place needs to be multiplied by 10. So if you want to see that method, come on in and I'll show you. But let's look at this. The sum of the digits is 3. We're just going to guess and check. Yeah, if the sum of the digits is 3, this is 0, 3, 1, 2, 3, 1, or 3, 0. Okay, so this is the small. When you reverse the digits, it increases the value by 9. So this would be 3, 0, 2, 1, 1, 3, 3, 0 becomes 0, 3. So which pair is it? When I reverse the digits, it increases the value by 9. Right there. Yeah, the sum of the digits is 3. When you change it by reversing the digits, the value goes up by 9. So we have 12 and 21.